Good morning, everybody. Last class we had started with fluorides in dentistry. We had discussed about the introduction, about fluoride, the history of fluorides in relation to dentistry, and metabolism of fluorides. Today's class will be on mechanism of action of fluorides in caries prevention. We had also covered about fluoride toxicity, that is the acute and chronic fluoride toxicity in the last class. So today we are going to talk the other part of the fluoride, that is the beneficial effect of fluoride, wherein we will be discussing about mechanism of action of fluorides in caries prevention. So broadly, there are 5 different mechanisms of action of fluoride in relation to prevention of dental caries. So last week when we had discussed about toxic effects, I told you fluoride acts as a double-edged sword as far as dentistry is concerned. So at low concentrations it is therapeutic, and at high concentration it is toxic. So today we will be discussing about what are the therapeutic effects of fluoride. And this is a main question as far as your exams are concerned. It is a long essay question. So mechanism of action of fluorides in relation to dental caries can be broadly categorized into 5 different mechanisms. The first mechanism is called increased enamel resistance or reduced enamel solubility. The second mechanism is called increased rate of post-eruptive maturation of enamel. The third is remineralization of incipient lesions. Fourth is alteration in tooth morphology. And fifth is interference with caries microorganisms or plaque microorganisms. So we'll be discussing each of this a bit in detail. The first mechanism, increased enamel resistance or reduced enamel solubility. What you need to understand is that you all know enamel is made up of hydroxyapatite crystals. Okay, so hydroxyapatite crystals have a formula Ca10PO4 6 times OH twice. This is the chemical formula for hydroxyapatite crystals. And enamel is made up of this hydroxyapatite crystals. You are all aware of that. And it is basically a mineral made up of calcium, phosphate, and hydroxyl group. So usually what happens is when this hydroxyapatite is there, when the pH of the saliva falls below 5.5. 5.5 is known as the critical pH in relation to caries. So critical pH means it is the pH below which the demineralization of enamel occurs. So in relation to caries, the critical pH of saliva is 5.5, a pH below which the demineralization of enamel occurs. So we all know as we consume food, you have all heard of Stephen's curve in biochemistry. As soon as glucose enters into the body, you see a drop in the salivary pH. Okay, so always your oral cavity is subjected to repeated eating. So whenever we eat food, what happens is there is a drop in the salivary pH, and when the pH goes below 5.5, usually this hydroxyapatite splits into calcium, phosphate, and water. This is a reversible reaction. Okay, so hydroxyapatite splits into calcium, phosphate, and water when the pH of saliva goes below 5.5. When the pH goes above 5.5, because saliva is equipped with lot of buffering mechanisms, you have heard of bicarbonate buffer, phosphate buffer, and protein buffer. So these 3 buffering mechanisms swing into action, and they try to neutralize the pH of saliva. So what exactly happens is when the pH goes above 5.5, the usual salivary pH is 7, or you can say 6.8 to 7.2. So when it goes back to that range, actually you expect a reversal to occur. That is, calcium, phosphate, and water should combine to form hydroxyapatite, but this does not occur. And because this does not occur, what happens is the reversal reaction is not 100%. So if 100% gets split into calcium, phosphate, and water, 100% is not converted back to hydroxyapatite. Instead, a more soluble mineral like calcium phosphate is formed. And this is the reason, in spite of there is a continuous remineralization, demineralization going on, the remineralization is not always back to hydroxyapatite. And that is the reason, in spite of all these buffering mechanisms in place, you still find caries occurring, because whenever the remineralization takes place, it does not get converted back to 100% hydroxyapatite. Instead gets converted to other more soluble minerals which are easily degraded by the acids. So that is why caries occurs in spite of this remineralization demineralization cycle taking place. routinely. So now coming to what does fluoride do? Fluoride forms a fluorapatite. So when this hydroxyl group is replaced with fluorine, it forms fluorapatite ion, which is much stable than hydroxyapatite ion. Hence, it increases the enamel resistance. Now, why does this combination take place? Is when hydroxyapatite is exposed to fluoride, what happens is the two hydroxyl groups get replaced with fluoride groups. So the formula for fluorapatite is C8NPO4 6 times F2, or one of the groups get replaced. That is when it forms fluorhydroxyapatite, that is C8NPO4 6 times OHF. So if one hydroxyl group is replaced, it is called fluorhydroxyapatite, or if both the hydroxyl groups are replaced, it is called as fluorapatite. Now this combination takes place very readily. That is because according to the laws of stereochemistry means it is the spatial arrangement of ions. So according to the laws of stereochemistry, a fluorhydroxyapatite or fluorapatite crystal is much more stereochemically stable than hydroxyapatite. So there is always a tendency for everything to go into a state of stability. So this combination takes place very rapidly as soon as the fluoride exposure is there to hydroxyapatite, because stereochemically fluorhydroxyapatite as well as fluorapatite is much more stable than hydroxyapatite. So that is the reason why this combination takes place. So that is what I was talking to you right now, that when pH increases due to the cessation of acid production, more of precipitation of minerals of calcium and phosphorus occur. So it is not 100% converted back to hydroxyapatite. So fluoride, other than conversion into fluorapatite, also helps in precipitation of hydroxyapatite. It prevents the formation of other more soluble calcium phosphate minerals. So whenever fluoride is there at the fluoride environment, when the demineralization taking place, it tries to convert most of the minerals back into hydroxyapatite and reduces the formation of minerals like calcium phosphate, which is much more soluble. So by this, it also reduces the enamel solubility. So the first mechanism is it increases the enamel resistance, that is by formation of fluorapatite. It reduces the enamel solubility because it tries to convert maximum calcium phosphate in water back into hydroxyapatite. It favors the formation of hydroxyapatite, and hence it reduces the enamel solubility. Now there is one more mechanism that is taking place. This was the formula I was telling you. Calcium hydroxyapatite when exposed to low amounts of fluoride results in formation of fluorhydroxyapatite. This is the formula for fluorhydroxyapatite, or it results in the formation of fluorapatite. So when one hydroxyl group is replaced, it is OH and F. When two groups are replaced, it is F2. So these are stereochemically more stable than hydroxyapatite, hence it is more resistant to acid attack, and thereby it increases the enamel resistance. There is one more mechanism that is called the role of carbonate. It is called as the carbonate theory. This is another alternative explanation for the effect of fluoride on solubility. Now what is this is? Carbonate is known as the Achilles heel of enamel. Now what is Achilles heel is? It is the weakest portion of enamel. So when carbonate is usually present during the tooth development, and if at all it is present, it reacts with hydroxyapatite to form carbonated hydroxyapatite, and it is very structurally weak substance. So later when these teeth erupt into the oral cavity, this carbonated hydroxyapatite is easily susceptible to caries attack. So if fluoride is given during the time teeth are developing, it replaces the carbonated hydroxyapatite and forms fluorapatite, and the erupting teeth will have much more enamel resistance, and hence it is less soluble. So this is the role of carbonate. Also understand that this role of carbonate is purely a pre-eruptive effect. The meaning of pre-eruptive effect is the fluoride has to be exposed within the jaws when the teeth are developing. So that is possible only when fluoride is given systemically. So when you talk about fluorides, there are two routes of administration. One is called the topical. Topical is you are directly applying onto the teeth. So second is called systemic. Systemic, the fluoride is swallowed, it goes into the stomach, it gets absorbed into the blood, and it gets distributed to all these organs. So what happens in systemic fluoride is when the teeth are developing within the jaw, whenever fluoride is given systemically, it goes through the bloodstream and reaches the developing tooth, and that is when the carbonated hydroxyapatite is replaced with fluorapatite. So carbonate theory says that carbonate is present as an impurity during tooth development, and it forms carbonated hydroxyapatite, which is known as the Achilles heel, which means it is the weakest portion of the tooth. And this, once this tooth erupts, the carbonated hydroxyapatite is readily undergoes demineralization, resulting in caries formation. So weight fluoride is applied at the time the teeth are developing, and this has to be systemically. Only then it readily forms fluorapatite or fluorhydroxyapatite, and thereby it increases the resistance and reduces the solubility of enamel. So this is the first mechanism of action of fluorides in prevention of caries. So it is broadly written as increased enamel resistance or reduced enamel solubility. You have to talk about fluorapatite, you have to talk about the role of carbonate, and you should also talk about the conversion of minerals more towards hydroxyapatite, which is done by fluoride. Now coming to the second mechanism. The second mechanism is increased rate of post-eruptive maturation of enamel. Now what is the meaning of post-eruptive maturation? This also you must have read in your DADH classes. Post-eruptive maturation is, you all know, whenever the enamel erupts, whenever the tooth erupts into the oral cavity, the enamel is not 100% mineralized. There are hypomineralized areas of enamel. The examples of your hypomineralized areas, as you all know, include your enamel tufts or enamel spindles, enamel lamellae. These are all areas which are hypomineralized. Hypomineralized is they have not yet undergone complete mineralization. So this, what happens is, as after the tooth erupts into the oral cavity, over a period of few months, with the minerals from the saliva, this hypomineralized area undergo complete mineralization, and this process is called as post-eruptive maturation. So I repeat, whenever the enamel is erupted into the oral cavity, it is not 100% mineralized. It has many areas called as the hypomineralized areas. These are those areas where the mineralization is not yet complete. The examples include the enamel tufts, enamel spindles, and enamel lamellae. And following eruption, what happens is these hypomineralized area undergo a period of complete mineralization over a period of few months, and this procedure on a total is called as the post-eruptive maturation of enamel, which is a very slow process. Now what happens when fluoride is given this time is, whenever at this point of time, that is as soon as the tooth erupts, fluoride is given, the rate of post-eruptive maturation, of the speed at which this post-eruptive maturation takes place, is faster. Thereby, during the period of post-eruptive maturation, the tooth is at a risk of caries. So whenever fluoride is given, the after time, that is as soon as the tooth is erupted, the speed at which this maturation takes place is faster. So remember this mechanism. It is called increased rate of post-eruptive maturation. Understand that post-eruptive maturation is a natural physiological process, but fluoride enhances the speed of post-eruptive maturation. And that is the reason usually fluoride is recommended at 3 years, 7 years, 11 years, and 13 years. We will be discussing this in detail when we discuss topical fluorides. The ideal age of application of fluoride is 3, 7, 11, and 13. And this means that this is the time when you have freshly erupted teeth. At 3 years, you have the freshly erupted deciduous molars. 7 years, the first molars and central incisors. 11 years, the premolars. And 13 years, the second molars. So these 4 age groups, you have the maximum post-eruptive maturation taking place. So the ideal ages of application of topical fluorides to prevent caries is 3, 7, 11, and 13. So with this mechanism, we'll stop this video. I'll continue with the other mechanisms in the next video. So far we have discussed 2 mechanisms. Thank you.